mechanics. The purpose of this course is to understand various things about quantum mechanics, starting from very beginning. No prior knowledge of quantum mechanics is assumed. All we need is to keep an open mind and to try to understand this fascinating science known as quantum mechanics. In this course, we'll cover various questions about quantum mechanics, starting with what is quantum mechanics, why we need it to explain things at the microscopic scale. At the macroscopic scale or the large scale, the things are well explained by Newtonian physics and the theory of relativity. But these theories break down at very, very small scale, and one needs a new theory to understand the phenomenon at that level. Quantum mechanics explains things that classical physics cannot, and more important, it exactly matches the experimental results at the microscopic scale. To this date, quantum mechanics has explained every single experimental result that has ever been obtained. It has never failed even once. That shows how good and accurate quantum mechanics is to explain things at the microscopic level. So in this course, we'll start with what is quantum mechanics, why we need it, where it came from, and who are the people who played a fundamental role in discovering this new science earlier in 20th century. And we'll also discuss applications of quantum mechanics to science, where we'll see how quantum mechanics helps to explain atoms, molecules, solids, superfluids, superconductors, and condensates of cold atoms. Then we'll look at the applications of quantum mechanics to technology. For example, microchips, lasers, MRI machines, quantum computers, quantum encryption, and quantum communications. And we'll end this course to gain a keen insight into nature by understanding how quantum mechanics is absolutely essential to understand the laws of nature. And things like God particle or the Higgs boson that was recently discovered, a number of dimensions, extra dimensions, theory of everything is also known as theory of superstrings, multiple universes, elementary particles, and their properties. So let's start with why we need quantum mechanics. So quantum mechanics was a science that was discovered earlier in 20th century because before that, physicists had accumulated a lot of evidence on things like atoms and molecules in the 19th century, and those experimental results just didn't make any sense in terms of Newtonian physics. They could not be explained. So people tried different things. They tried to extend Newton's laws, but no matter what they tried, it never did work. So it became understood that there is something happening at the microscopic scale where the laws of Newtonian physics completely break down, and we have to look for something new. And unless that new theory makes a complete departure from Newtonian physics, we'll never be able to understand these phenomena that were being discovered at the microscopic scale. The most important phenomena was the light emitted by an atom. So people had done experiments using a technique called spectroscopy to measure the light that an atom emits when it is excited and it falls to its original unexcited state. And it turned out that this light always was emitted in discrete wavelengths. So that didn't make any sense because Newtonian physics says that energy should be continuous. So why atoms were emitting light that was always discrete?